Oh, look at this. The lights slowly dim, and it's like you know that bit before like a show where you're actually going to see Led Zeppelin and the lights come down. It's nothing like that at all. Hello everyone and welcome to Fusion. I say how awesome it is to come back in the summer. I'm sparing you me running around the stage because my clicker doesn't work properly. So now I have to stand at the podium, which makes me feel very uncomfortable. The lift music in the background, do you reckon we could just not have that? Yay! That is a random insult across the room. So for anyone that came to Fusion last time, you probably would have seen my dreadful joke that my colleagues told me that went on for far too long for an NFT joke, which is probably true. So I'm going to save you this time, but obviously you all know that I have to start off with some sort of humour, don't I? So instead I've just thought I'm just going to go straight and do a dad joke. I can't do any jokes about crypto or NFT or things like that because the jokes write themselves and it's almost too easy. So here we go. Roses are red. Drop table rhyme. Hope you sanitize your inputs next time. Hey! And that was genuinely stolen from Twitter this morning by Carla, not a robot. And that's kind of it for the humour. This is a tech event after all, so you know we're not comedians, or some of us pretend to be. So we've got three amazing speakers tonight, which is hopefully why you've all come. Obviously not to see me make an idiot out of myself, and what a lineup we've got. We've got the Guinness World Record holder for being Safari's biggest fan. We've got an engineer passionate about monoliths and works for Challenger Bank Starling. And we've got the staff engineer in SOAP APIs at US giants JP Morgan Chase. And I will let you work out, of course, all of those things are not true. Let you work out which speaker is the opposite of those things. Catering by the Indian Brewery, let's hear it for the Fat Nards. Absolutely love the naans that they do. Right, we can't do this, obviously, without our sponsors. So shout out to our sponsors. We have obviously a talk from not from JP Morgan Chase, but from Goldman Sachs. So thank you. A big shout out to Goldman Sachs and to Mark Perkins, who's here tonight, and to Vonage. And I can't say anything mean about them because they also employ me. We'll hear a little bit more from Vonage a bit later. So, also, sponsorship opportunities. We are looking for sponsors, so if you want our package, let us know, give you some info. So, always on the lookout for sponsors. Partners, if anyone has been to Fusion before, you'll see that this might look slightly a bit different, but we regularly try and support and partner with people in the Birmingham tech ecosystem. So, Cryogenics is always on there, Stuart Langwood, who's here. School of Code. Hack the Midlands, got some Hack the Midlands in tonight, including its main organiser, Mind, the mental health charity, and Code Your Future. Claire Bickley might be sort of returning to duty soon after maternity leave. And new on there, Birmingham Design Festival. Dan Alcon did an app, for those, some of you might have gone to it. Did anyone go to Birmingham Design Festival last week, the week before? Absolutely nobody. Room full of engineers. It was absolutely fantastic, and the work that goes into Birmingham Design Festival is phenomenal, and the calibre of speakers they get is brilliant. New to this, you'll see that there's some missing names on there, but they're not missing, so I'm going to do a little bit of a reveal. Ooh. What is this, Jim, you ask? This logo, hastily put together by Alistair Hay. Tech Midlands is a thing that is happening, and what it effectively does is an umbrella organisation that aims to help other meetups, such as these ones that count themselves among the groups that are associated with it. So that includes us, but also Brum JavaScript. If anyone's not been to Brum JS, it's here, and it's absolutely amazing. The Golang meetup, which at the moment is an advanced at the mailbox. DevOps, that's the DevOps Days logo, but DevOps Birmingham is happening. I'll get onto the date in a minute. Coffee Ops happens in the morning. I'll show you the dates for that, it's an informal kind of DevOps chat in the morning, which is quite cool. U equal Tech Midlands, which happened this week, or last week, which was cool. Some of you may recognize that logo. That's my old Meetup, Run PHP, which has mysteriously appeared on there. That's going to be coming back. Looks over to Dan in the corner. That's going to be coming. And then there's a hole there, and that might be your Meetup. The idea of Tech Midlands is to support, so there is funding. If you need a space, if you're thinking about starting a Meetup, go and speak to Luke or Alistair, or me, through them, who are at the back. They're waving their hands. The idea is that we are now starting to propel the Birmingham tech ecosystem, which, to be honest, post-COVID is accelerating quite rapidly and is a bit surprising, so it makes me kind of happy. Events, so I did say there was going to be events, so here's the calendar. Take a photo of this if you want to go to some stuff that's coming up soon. So we've got UX Huddle, Coffee Ops is in the morning. I can't remember where the coffee shop venue is. Is it York's? They're not going to shout it out. Well, what's it? Faculty. And Lab Chat, speak to Luke at the back for more information about Lab Chat, which is a bit more of like in-depth topics, like topic dives, which is a new meetup. And then Brum.js, which is here. Other housekeeping stuff, code of conduct. There is a code of conduct. The code of conduct, the short version of it is be nice to everyone and don't judge people on race or gender or sexuality, etc., etc. But if you want to see the full code of conduct, it is there from codeofconduct.com. We use a general one that encompasses everything. It's kind of borrowed off the Python one, if I remember correctly. If anyone feels like there's a violation of the code of conduct, speak to an organizer. That is me or Mike at the back, or Indy, who is somewhere, and James Vickery, who is standing at the back. And now the important bit, what you actually came here for, not to see me. So our first speaker, who yes, like I said, is not at JP Morgan Chase, is actually at Goldman Sachs, is James Mason-Drust, where you should be in front of me. I'm looking the wrong direction. Yes, platform engineer. Sorry? Not quite. Wow, my intro was going fantastically well. In my defense, finding your bio online was really difficult, so I might have to let you do something. Right, I'll tell you what. I will then introduce him and he'll talk about himself, and then I'll big him up afterwards. Can everyone give a warm Fusion round of applause for James?
Hello. Where do I pick up from there? Jesus, that's hard.
Sorry, I'm very loud.
Yeah, I've got it. Oh, nice. Hey. So let me give a short introduction about myself then. So born and bred in Birmingham. Oh, am I going too far back? Probably. But my first role out of university was with SideTrade. Where's SideTrade? Can we get a cheer? Oh, just two. Oh, James V as well, yes. And Maria, hello. And then spent a few years there doing a bunch of different roles, professional services, data engineering, a little bit of data science, and then moved over eventually into software development, and then joined Goldman Sachs. And I've been here since the inception of the Birmingham office. So I'm going to try to keep this talk pretty short, because I would love to do a Q&A session at the end. We're new to Birmingham. It's the first time we've opened an office here. We've scaled from, when I first joined the team, 3 people working out of small little meeting rooms in WeWork, and now we've got 250 people. So it's a fantastic place, and I'd love to talk about it a little bit more. But at the moment, I want to talk about our open source projects. I've picked 3 from the front of the website. I literally just went and got a screenshot. So if you go visit there, you'll see the exact same 3. And one of them, I'm going to go into a little bit more detail on how we, in our project, sort of hack it. We use it a little bit differently to do some cool and interesting things, I think, personally. So what are those open source projects? So we've got GS Quant, we've got Goldman Sachs, JDMN, and Legends. So let's go into GS Quant. Obviously, a large part of our business is being able to understand risk and the markets. Our quants have created a huge toolkit that uses a bunch of different inbuilt services within GS, and we've open sourced it. This is a massive Python library that anybody here can use. Perhaps up until about 7 days ago, you'd be using that to understand the cryptocurrency markets. And if you was, maybe you would have realized it's a little bit too risky and got your money out. But anyway. We also have a marquee connector built into GS Quant. That is our API. Unfortunately, you have to sign up for a developer account. It's a bit frictionful, but if you complete that step, you can get access to a bunch of GS data too. What is DMN? That's an interesting thing. So that stands for Decision Model Notation. That's a really cool piece of software that it's an engine. You can define a bunch of business processes, a decision path. Should this customer be able to open up a bank account with our bank? Shout out to Monzo. And basically, you can define the state of all the variables that you've got in this big process diagram, and then you will pull it into the engine, evaluate, and it will tell you what the decision is. I think that's a really cool piece of software because a lot of problems are just big decision problems. And it's very similar to just the path that you propagate through on a decision tree, once you've got some sort of record. And last but not least, Legend. Legend is a big, big ecosystem. I'm only going to be able to touch on a very, very small subsection of Legend. So we have an internal version of Legend called Alloy, but we have open sourced a very small subset. And it briefly consists of 3 parts. So we've got Legend Cube. Legend Cube allows you to go and look at all of the firm's data or whatever it's connected to in a very visual way. So it's a very visual web application where you can connect to any sort of data source, and you can apply models on top of them. So the data doesn't necessarily need to be structured. And you can browse everything that's available within the organization. On top of that, you've got the Alloy or Legend, Studio, which is what I described earlier. You can build these models and these data types that you will apply on top of the data sources. So I'm going to just quickly move into a small demo, actually, of Legend. It's about 5 minutes, and it's just a quick walkthrough about how anyone, I think, will be able to create these models and actually start contributing. And I think it's important to note before we go on why it's so important to model information like this. Data has very recently, in the past 10 years, become the most valuable asset to any organization. We can extract value out of it, create new customer experiences, create brand new products. And I think it's really important that we can get that ability to analyze information into the hands of absolutely anyone within the firm. We all have ideas, we all have fantastic ideas, but if we don't put the tools in front of the correct people and allow it to be an easily seamless process to analyze and build dashboards and understand the information, then the ideas won't ever flourish. So I'll try to be as quick as I can over the top of this. So here is the very simple user interface. You can see it's built on top of the open source VS Code. And it all happens within a Git repository, and you've got this folder section on the left-hand side. Underneath the hood, we've built our own programming language called the Pure language. It's sort of a mesh between UML and OCL. So that's Object Constraint Language, I believe, and Uniform Modeling Language. So I'll play it through, and what we're going to see is we're going to see the user create the models in a very visual way via a diagram. So let's give this a play. So the user's come in, he's going to go and create a diagram. In this case, he's aptly named it. As we all know, naming variables is the hardest thing to do in programming. And we're creating some classes very simply. And then we can start creating relationships between those classes. And this is all very A, B, C sort of stuff. We can have just generic properties. And on top of that, we can also have some sort of inheritance structure. So whenever you're dealing with any sort of programming language, whether it be a visual language or not, obviously there's three main things. It's what are the base things that we can do? So in this case, it would be classes, it would be properties, and then how can we then compose those things together to create more and more complicated objects? And so that's the idea of composition, and you'll see that very shortly. And then on top of that, we've got composition, and lastly, we've got abstraction. How can we abstract away the complexity and then carry on and build with those brand new units? And so here we've created a firm, perhaps some sort of company that is a child of the legal entity, and a firm has many people which are called employees. And so, as you might imagine, this may map on top of some sort of unstructured data in some data source somewhere. Or they may be using it to model a brand new system that they're trying to do. Perhaps they need to do some sort of CRM system, or perhaps some sort of internal employee holiday calendar booking system. So on top of simple strings, in a moment we're going to create some sort of derived expression. So as I mentioned, pure is a complete language underneath. It's got a bunch of functions. All the functions are very similar to the functions that you'd find in SQL and more. So we can also create constraints, and all of those are baked in to the model. So I think this is really easy. What do you guys think? Hands up if you think this is easy. Do you think you could do it after watching 5 minutes of someone create models? But this is going to blow your mind at the moment. So we've just created like a really simple model in a few minutes. And in a couple of clicks after this, we're going to be able to connect it to a data store and start pulling information. Now, that's pretty cool, all within this user interface. Again, you can create mappings. So you've got one model, in this service, maybe it looks like that, but in another service, it looks slightly different. So you can actually map those two models to one another. And here you can see that it's created a new person, which is perhaps the model of a person in a different service. And now he's configuring the mapping. So one of the services has a full name, whereas the other one has just a first and last name. And so this is how you go between the two. You just concatenate the strings. And then in the background, we've actually connected this very quickly to a data store. That is literally a 3-click operation if connectivity is all sorted out. And as you know, that may take longer. And once we are happy with that transformation, we can evaluate the things that have been executed. We can come down and click a new service. Now this is, I think, really, really cool. So we've got some sort of URL pattern that's been automatically generated, and we'll say, okay, this service, we want that mapping to be that service. And we just do a little bit of configuration. And in a couple more clicks, that's actually going to generate an executable, a jar file actually in GitLab that we can now execute, and we'll read information from that data store, and we'll transform it from the one model into the model we want to consume it in. And all in 5 minutes. I think that's absolutely fantastic. I think we can start being able to consume information in 5 minutes. What does that mean? It means we can start building custom dashboards on top of our data. It means we can very quickly and very easily start to visually see our information in new and exciting ways. So I mentioned that we use this tool, I think, in a very, very strange way, or a slightly strange way. It's a bit of a hacker mentality, in my opinion. So what do we have here? We have some sort of modeling tool, and in services, in object orientation, we want to model all of our objects and all the relationships. The service layer, when we're building code, should be really, really thin, ideally. And so all of that information, all of the domain expertise should go into the model. And we do that in Alloy, or Legend, sorry. And we put all of this information in the model, and we don't have to just put our application models in Legend. We can also put our API models if they differ. Or we could also put our database models if we're using more of a relational store. And it's got a bunch of interesting things, so I'll come back to those slides in a moment. So it's got a bunch of interesting things. It's also got a code generation tool. So because we've got the pure language underneath this tool, we can then parse it with a tool like Lex and create a completely different syntax tree in a completely different language. So how do we use it? So this diagram depicts it somewhat well. We get that metadata that we've got in Legend, as you can see in the green, and then we have these transpilers that will create perhaps an open API spec from the models. And for obvious reasons, open API specs are fantastic. It means that we can disentangle the front end from the back end teams. It means that they can work in parallel instead of them working in sequentially. We can generate all of our Python classes, and so the idea of the programmer is to wire all of these things up. All of the knowledge is encoded in those class files, and so we can split, we can make them parallel, and we can fake out the services before they're there. And I think that's the most important thing, actually, is being able to fake the backend before it's implemented. So we can now work on the user interface, we can work on the UI very quickly. We can start to get, and we can shorten the cycle of feedback from the user. So it means that we can create a contract, we can create some usable experience very early on, so we can get feedback and perhaps improve, because we're never going to get it right first time. We're modeling really quite complicated things, and it's never right first time. We have to get loads and loads of cycles. And if we didn't have a tool like this that allowed users to very easily and quickly change the data model, generate brand new pieces of code, and use templates to then inject that generated classes and the generated code into the correct places, and then rewire them up in a very quick way, it would mean that we'd have to wait until a whole feature was developed to get feedback. And we really want to shorten that down so we can get more and more iterations in, and so we can improve the user experience as quick as possible. We can get that feedback as quick as possible. So I think, to go back, I sort of very quickly brushed past the fact that we've got these contracts being generated from the model. We're creating our API payloads from through Legend, they're then being parsed into an open API spec, parsed and generated into an open API spec. So why are contracts really important? So if we come all the way back, when you've got a contract, you've got clear and concise requirements. It's unambiguous. We can amplify collaboration between people because before the backend service or any code is written, we've got a place where we can all look at and point at. As you can see, after 5 minutes of looking at Legend, we could all felt comfortable with it. We all feel like we could edit it. So we could have many different people from different backgrounds all collaborating in a single space before we actually do any development. We've got strong guarantees, and so if we are writing C, for example, we're all used to in header files we tell the programmers what functions we're going to include in the C file. Or in Java, we're creating interfaces, or in Python, perhaps, if we want to be particularly typed, we're creating abstract base classes. We're creating guarantees. This is what our service is going to do. We're almost creating some sort of domain-specific language for our service. And I think that's really important that we get the domain-specific language really right. Because if we can express our problem in a real clear and concise language, I think it makes it easier to build more complicated things, because it's succinct. And if you've ever used a really good API or Python or any sort of package or module, I think you'll also agree. And obviously code generation, if we can inspire developers and help them by reducing the amount of boilerplate code, we all write it, we all hate it, let's minimize it. We could use things like open API spec generators and with custom templates. So even if you're using a really rogue framework, you can write your own templates in Mustache, and you can leverage that to generate all of those boilerplate code. And like I said, decoupled work streams, it means that the UI can completely be separate from the backend until they integrate. And the fact that you've got a contract there, that strong guarantee, that means that's less of a problem. You know, we've all been there when these things have been really coupled, and then when we try to put them together, you know, you go through weeks of just back and forth. Oh, there's a small problem here, there's a small problem there. And I think this is, you know, agreed upon really fantastic standard that not a lot of us actually do. And I think it's a really low barrier to entry that we all could start doing it. And this is why I really want to preach contract first design. So like I say, the workflow is, it means we can prototype really quickly. That may be creating some sort of low fidelity mocks with a UX guy, and then letting the user use, and then from that we can figure out what's our data access patterns and things like that. And then from there we can start developing this contract, and we can publish it to somewhere so we can all start collaborating and we can all start changing it. And then from there we can generate code and really quickly build out that service. So it's just a pictorial representation of what I was talking about earlier. It means once we have that mock in the background, it means that the back-end team and the front-end team can be separate. So on the left-hand side is what is code-first approach, and on the right-hand side is the contract-first approach. So like I say, Alloy is a fantastic tool. It's fantastic for being able to analyze large pieces of information, but perhaps there's a different application. That application is creating these models that can create these contracts, that can generate code, that means that we can increase our velocity, we can increase our agility, we can decouple work streams. So we can actually start building on features very, very early on. So this is a small diagram that we've got for the projects that I currently work on. So, you know, we've got these really thin domain contracts. We, you know, API, the ways that our API looks is very similar to how our information is stored, and that's not fantastic for users in general, but it's really easy to program. And as you saw with Alloy, we've got this ability to create model-to-model mappings. We can spin these servers really quick and really easy. So what if we define just one more contract? And that contract is an experience contract. And that experience contract is an aggregation of all the domain contracts that we have. And we define a mapping that maps all the domain services to our experience service. And then we can version that with open API versions. We can do the model-to-model mapping. We get that for free. And our users can have a fantastic experience whilst not being a burden to developers to create API payloads. So I don't have anything more to talk about now. So I'd like to open it up to the floor. If anybody has any questions about, in general, Goldman Sachs in Birmingham, what we do, or about this talk, please ask.
Thank you very much.
I could just run over there with this and be like,
That'd be quite good. Use up plenty of energy on it.
it'd be quite awkward as well.
I love the fact that AV has left at the point that we're going to do a Q&A.
Oh, la, 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 la.
That's pretty
Does anyone fancy projecting their voice if they have a question?
Does anyone shout their question?
Yes, sir. I'll just come to you. That makes it so much easier. And I'll repeat it.
Work streams can kind of go in parallel on that. So what happens then if there is, like, you know, at some point later on, say the back end finds out, oh, actually the constraint can't work like this.
Okay.
So
that was
is
on.
there like do you have like a method built in to then push that to both work streams at the same time?
So the question was, for anyone who didn't hear, I claimed that you can decouple the UI and the backend work streams, and what happens if that contract inevitably changes over time, which it will, because when you change contracts, you're going to break a lot of people's code, you're going to make them really, really sad. So we have a centralized place that we generate all of that code. As you can see, that's all within Alloy. We've got our own repository called contracts, or whatever the project is. Perhaps we're naming it after cocktails, and I really like Fireball, so it's called Fireball Contracts or whatever. All of the code generation works directly out of that repository. That repository will then generate the open API spec, and I mean, we could just create a really small bash script that will pull the relevant UI repository if it's in a different place and make a commit on a particular branch. And then perhaps send a Teams notification to let everybody know. And then eventually we'll be able to notify everyone. I mean, obviously we need to version the releases, of course, because we can't have things changing all over the shop. Things need to go in pairs, but the open API specs are versions so we can tag the releases to production. Does that sort of answer your question, if that's okay? Okay, fantastic. Does anybody else have a question?
Cool, we actually have a working mic. Hello.
Oh, fantastic.
There's a hand, there we are. Right, off I go.
So what code is actually generated as part of this?
So as part of this process, what's generated at the other end, or what does Legend generate, or what can we generate? What does Legend generate after you define the model? Yeah. So Legend itself has this pure language underneath the hood. So just to let you know, this whole platform took 7 years to develop. It took a very long time, and then Goldman Sachs actually open sourced it in, I think it was July 2018, I think. So yeah, we've got this pure language underneath, and I know internally we have a bunch of standard generators that are built. So we can do things like generate JSON schema. We can generate Python classes. So internally we have a module called PyPure, which we can create one of the generation services. It will generate Python classes, and those are implemented via some module called PyPure internally. So you can create your own parsers with Lex and do whatever with it. Does that sort of answer your question? Or am I not hitting it?
So it seemed like you were generating a model that roughly translates to a SQL, a relational database. And I'm wondering, does that generate a SQL for you, and then the API codes will interact with the database as well?
Oh no, we don't generate any SQL. There's nothing built into the tool that will generate SQL. Like I say, we can generate application code, we can generate JSON schema, with some other formats as well internally. So we've got Avro, which I'm not familiar with at all. We can build Java classes. So it is very much centered around application classes. But the way we hack on it is we can get JSON schema that's really easy to parse and mess around with. And so that's what we do. And actually the JSON schema generator has an Open API Spec 3 dialect, because as we all know, the JSON schema in OpenAPI is actually shifting. They're actually diverging away from JSON schema. So in the V1, I think, of OpenAPI, it used to be JSON schema directly. But now, as they're going through the versions, they're actually diverging and creating their own sort of language. Is that, yeah, fantastic.
Cool, I've got time for one more question. If there are any hands, I'm also going to check to see if we've got any from online. Yes, we do have one from online. So, from the chat room, question, do you allow for automated testing for the contracts for integration tests?
Oh, fantastic, yeah. So you can use something called, we build our code in our project. We use Python for our services, and there's a module called Schema Thesis, and all you have to do is feed it an Open API, and it can generate literally hundreds of tests. It can read the schema, generate the the payloads and then send it off and see what happens. You know, does it give the correct responses? And so to the person online, yeah, look into the Python module schema thesis. It's a fantastic module. And so that's how we can make sure that the application that we're actually written guarantees the contract. That's a very important piece. Else, when you come to integrate, you're going to have chaos still. Like if we didn't do something like that, all of the benefits of contract first would be quite pointless, I think. So yeah.
Cool. Thank you very much.
We've got one at the back, I think. Do we have time?
What was the motivation for open sourcing the project?
Good question. I think, you know, in finance, we're modeling very complicated products. And, you know, these products are shared between a bunch of organizations. And so why shouldn't we all be able to collaborate on building the models for these products? I think there's a project that's come out the other side of it. It's called FOO, Financial Object Something Group. It's like a working group that's doing exactly that. So it's a JV between a bunch of large banks that are now trying to model all of these products in a standardized way. So if you're interested, please take a look at FOO, I think it is. Just type in Finos, FOO, and you should be able to get some information about it. Thank you.
Cool. Right, everyone give a big hand to James. That was very cool, and yes, in general, Open API, just what you can actually do with it generally sort of blows my mind. Right, whilst we wait for our, this is like clearly the first toilet break. Everyone's like, yes, quickly get it in, get it in. Right, so you're waiting for Will to set up. And there we go. Hopefully this will be very, very seamless and you won't have any more jokes because my team are extremely unhappy with my jokes. There we go. Right, so our next speaker, I wonder if you can guess where he works. And I enjoyed writing this note. So platform engineer at Monzo. 6 years at Pusher? Yeah. 6 years at Pusher. Anyone might have, some people in the room might be familiar with Pusher, I think. And unlike me, you seemingly actually know how to play Cities Skylines, which I don't because I find it very confusing. Just SimCity 2000 will do me. So, here to speak on this, which, if anyone's seen that blog post for about 5 or 6 years ago where Monzo said, here's what our microservices look like, and it just blew my mind. If you want to see how Monzo deployed to production over 100 times a day, here is Will Sewell. Give her a hand, everyone.
Thank you. Hello, Birmingham. It's good to be here. I think last time I was here, it was winter. I've only been here one time, and that time it was winter, and it was very bleak. And I walked up from the station today up here, and it was absolutely beautiful. So really nice to be here. Yeah. So I'm Will. I'm a platform engineer at Monzo, and I'm going to tell you how we deploy to production 100 times a day. If you're not familiar with Monzo, we're a bank, and we're famous for our hot coral cards, as we call them. But this is hot off the press. We have some like new neon cards. If you want to get these, you refer 2 people to Monzo, and you get a cool card. So do it. But that's not what this talk is about. It's about deployments. And why am I talking about this? Because Monzo, you know, if I went to our CEO and said, hey, we deploy to production 100 times a day, that's not really what he cares about. What he cares about is taking ideas and getting them into the hands of customers quickly, because this lets us iterate on new features, it lets us respond to customer feedback quickly, it lets us fail fast if we need to, if something's not working. So that's why we care about like a high velocity of shipping, essentially. And the number of deployments is really just a proxy for that. It's a bit of a it's a bit of a vanity metric. It's a bit of a, a bit provocative talk title, put it that way. But it's something that we do to check that we're on the right track with this kind of thing. So in this talk, I'm going to kind of go into, I've only been at Monzo for just over a year, so I can't really claim credit for any of this stuff. It's basically what I've reverse engineered from being at Monzo. So I've observed, I was surprised when I joined at how fast and how startup-like the organization was given the size. I think we're about, thousands of employees, and I'd say probably about 200 engineers, something like that, to give you a sense of the scale. So I was kind of figuring out how we had maintained that very fast shipping velocity despite having grown quite significantly. So this talk's my effort of explaining what I think that is. But before I go into that, I'm just curious to get to ask you what size company you work for, because I think your experience of shipping velocity will depend a lot on the size of the business. If you're a startup, this should be the default. You should be shipping very, very quickly because the overheads are not so great. The risk is not so great at that point. So let's see a show of hands before I dig into this further. Do you work for a company that's fewer than 30 employees? Okay, so not so many. Okay, what about 30 to 500? More? More than, let's say more than 500. Okay, so that's the majority. Interesting, interesting. I had no idea what to expect then. So this might be for you then. So typically what happens is startups move very, very quickly, and that's how they can compete with all of you who work at larger companies. And what typically happens is as companies get bigger, they get slower. And unless you put a lot of effort into counteracting that, this is what will happen. And it happens for a few reasons that I've listed here. So I think a big one is risk aversion. If you're a big company, you probably have a much more valuable product than a smaller company, typically. You probably make more revenue, that's why you can afford to hire more people. But that means that if things go wrong, then it's more expensive. You will, there'll be more of a financial cost, there'll be reputational damage. So you introduce more of a arduous change management process to manage that kind of risk. There's other issues as well, so you have more engineers working on the same system, so there's an increased chance of contention, so you might have to wait for another engineer to finish the changes that they're making before you can deploy your changes. That kind of thing becomes more common. And just the final point is that the net cognitive effort that's expended to understand the system increases as well. And this is particularly bad if the sort of technology becomes more and more heterogeneous. So you use more and more different kinds of technology in your organization. New joiners have a lot more to learn before they become productive, and if you move team, you have more that you need to get your head around before you become productive as well. So all of this is friction. This is I actually wrote this up in a blog post that I published recently, and I shared it on the DevOps subreddit, and this is a comment that someone made, and it might resonate with some of you. Typically, the large organizations, particularly in a regulated industry like banking, you start to see this kind of thing happen, where it takes a very, very long time to go from idea to that idea getting in the hands of customers, and that's something that we try and avoid. I want to dig into the risk aversion point a bit more, because I think this also often comes from a well-intentioned place, but typically the obvious solution to reducing risk is to add red tape. That can mean many things. It can mean you need to get sign off from 3 engineers, one of whom is level X on the career framework or whatever you have. It might mean that you need to do extensive quality assurance before things get deployed to a production environment. All of these things add friction, and what happens when you add friction to a process? It means you don't want to interact with that process very often. And when you don't want to interact with that process often, it means you start to batch up changes so that, you rather than deploying frequently, you're going to deploy once you've finished all the work. And the problem with that is it's a bigger change. And bigger changes are more risky. There's a bigger blast radius because more has changed. And they're typically much harder to revert if things go wrong as well. So this is like the opposite of what we were setting out to do with this red tape. And yeah, we end up with the worst of both worlds, essentially. So at Monzo, we try and solve this problem in the opposite direction. So we try to remove as much friction from the process, from idea to in the hands of customers as we can. I work in the developer enablement team, so we're mostly focused on like the deployment pipeline, and that's what I will focus on for the rest of this talk. So I'll kind of go into like the mostly sort of principles and culture that I think enables this frictionless deployment process. Oh yeah, and like this isn't just me sort of, we're not just guessing here. We track a lot of metrics around this stuff. So the 100 deploys a day is very much like again, like I said, a vanity metric. You can make that go up probably by hiring more engineers, but hiring more engineers often without doing anything else will lead to a reduction in deployment velocity per engineer. So what we have is, and I think it's really cool, is this is a year's worth of data on the right-hand side. It shows the average number of weekly deployments per engineer. And the cool thing about this is like, it's not going up. I'd love it if it's going up, but it's not going down. And we've grown a lot in the last year. And this basically shows that we have a really nice property where we can essentially hire more engineers, and the deployment velocity scales linearly with that. We don't see a reduction. Like all of those overheads I mentioned previously, we're not seeing the negative impact of that, which is really cool. And we also want to control for risk as well. So we want to check that this really is not introducing more risk, the approach that we take. So this is also, again, slightly flat. I would like it if it was going down. But this is the number of deployments which are rolled back, which is a proxy for bad changes which are deployed to production, essentially. We also track lots of other metrics around incidents, which we have seen going down. So this is something that's, to us, proving that we're on the right track here. And how do we do this? So I'm going to talk about like the principles, essentially. I'm going to start with the engineering culture, because I think that's the most important thing. So our review process and our change management process is very light touch in terms of or light human touch. So we basically require a single review from any engineer in the company. And if you work for a startup, this is very standard. But as companies grow, this is quite uncommon, and definitely in regulated banking industry. We've had to put a lot of effort into convincing regulators that this is actually not increasing risk by doing this. So it's really I put this Russian proverb, trust but verify, which is meant to be a kind of tongue-in-cheek thing, but I think it describes our approach quite well. We trust engineers to, so what I've described here is the minimum. So the minimum requirement, the enforced requirement, is one review from a single engineer, but we let engineers decide and use their judgment to decide on the level of review required. Obviously, if we were making a change to some of our core banking foundational, data structures or databases, they're going to require a lot of scrutiny, and that's something that engineers are trusted to make that decision. What we invest a lot in is the guardrails monitoring and auditing. So by guardrails, I mean things that make it very hard to make the wrong decision. So also make mistakes, essentially. So this is warnings, like the thing I was showing below, just as an example. When you make a pull request, if you make a change to a critical service, which is a dependency of the app loading, then you get this warning on your pull request to say, hey, you might want to be a bit more careful here. It also means things that are enforced as well. So, for example, you can't deploy to production until a change has been deployed to staging first. Monitoring, we have, just by scaffolding a service, so creating a new service, you get a lot of stuff out of the box. You get lots of metrics like error rates, latency. You get a pre-built dashboard that graphs all of this stuff nicely. We also have out-of-the-box alerting. So if your service starts panicking or starts erroring at a high rate, you get alerted, and that's all stuff that you get for free. You don't need to, as a service developer, implement this stuff yourself. And auditing as well, so if stuff does go wrong, we want to be able to know why it went wrong, like who made the change and when, essentially, so we can figure out how to stop that kind of thing happening again in the future. And this is all through, we have like a really generic events pipeline, events fire hose. So any service can publish events to this fire hose, any other service can consume from them, but we have all of the events end up in a BigQuery database. So for example, our deployment system emits lots of events, and we have like nice dashboards which tell us what happened when, which helps us understand why things might have gone wrong if they do. The kind of, I see this as an absolute requirement of this decentralized, trust-based approach is transparency. So if we're trusting engineers to be making decisions around risk and judgments around risk, then they need to understand what the business's risk appetite is. And this is something that we are very transparent about. So we have tooling for tracking incidents and record all of this information, like incident severity, frequency of incidents, and we track this against top-level business objectives, which get shared around the company on a regular basis. So this all gives us like a sense of how we're tracking, and if we're tracking in the wrong direction, then engineers start to prioritize risk reduction and a bit more scrutiny over changes than they might normally have done. And we see at a more decentralized level, teams implementing things like SLOs more on a team level, but this isn't something that's mandated across the business. And the final part on culture is our blame-free incident post-mortem process. So the worst thing you can do is blame people. We use it, I mean, it doesn't help them, it doesn't help the business. So we use it as a way of tightening our automated process, all of those things that I've already mentioned. And from a purely practical point of view, if people are scared, they're going to spend a lot more time, if they're fearful of being blamed for mistakes, they're going to spend a lot more time, babysitting the deployment process, essentially, spending a lot of time manually checking that it's worked in the way they intended it to. And that's something that's going to add more friction to the process. And as we're seeing, friction is going to slow things down and make things more risky. So what we really want engineers to do is to just trust the process, trust all of this out-of-the-box, all of these out-of-the-box things that we provide them, so that they can just hit deploy and be confident that they'll be told if things go wrong without having to check. So that's the culture. And I'm also going to just talk a bit about our tooling and architecture as well, because I sort of see these things as like jewels of one another. So the engineering culture will encourage certain types of tooling to be built, some of which I've already mentioned, but the tooling also reinforces the culture as well. So these are the kind of principles that I think we use when we're designing tooling. So the first one of these is we want to create delightful tools, and this is something that like everyone wants delightful tools. But what do I mean by this? I think for us it means we want simple and opinionated tooling. So we don't, for example, we used Kubernetes. We don't want to expose the Kubernetes API to engineers. We want to figure out what the most common workflows are for engineers and optimize for those. Like, there's only a very small handful of functionality of Kubernetes that engineers actually need to interact with, and that's what we want to expose to them. So just to give you an example of some of these, and some tools that are very popular at Monzo. So one of them is what we call the pound CLI, and this is you just type like the pound symbol, and it comes up with a shell. And this is like the Swiss Army knife of sort of observability and debugging into production. So it lets you do things like query config for services, edit config, run RPCs against any service. We have things like multi-party authorization. So if you run a more risky command, you have to get authorization from another engineer to run that. It lets you interact with our queuing systems, that kind of thing. It lets you do like almost anything. One really small thing that it lets you do, which I want to show you quickly, it seems kind of trivial, but it's one of these like things that I think encapsulates this delight idea, is the find command. So every object in our system has a unique identifier. So that's things like, accounts, transactions, users, and you can type find in any identifier, and it will query it for you, and it will give you all this information about that object. And this isn't coming from like a single database. You can think of every service having their own mini database, really. And it will go to the right service and run the right RPC request to fetch that thing. Yeah. One other tool is Shipper. This is what engineers use to trigger deployments. It looks a bit like a wall of text, but you've got to remember when you're running this, it prints this information out like incrementally as the deployment progresses. And this, I think, just highlights some examples of some of the things I've mentioned, like some warnings about changes that other people might have made which are currently not deployed for that service. So it's saying, you want to deploy your changes, but it's also going to deploy these changes too. It prints the links to pre-built dashboards so you can monitor the progression of your deployment. And it also prints a rollback command, which you can copy and paste if you need to roll back. So as well as the delight, we also want to provide consistent and familiar workflows to engineers. And I think the reason we can do this is because we are very opinionated and consistent about all of the technical choices that we make. So we use the same programming language everywhere. We use the same database everywhere. We use Kubernetes everywhere. And this means that we can build a single set of tooling that will work across every single type of service. This is nice for us because we only need to put the effort in a single time. And it's great for engineers as well because they can move across projects without having to relearn everything. We also, I think automation is an area of active development at the moment. We have a CD, like continuous delivery for infrastructure changes. We're investing in that for services as well. That's the kind of gold standard. It's still pretty automated. You just run one command. But there's more we can do there. One kind of ironic thing about having a very smooth deployment process is what I've described at the bottom there. If it's very easy to deploy to staging, engineers are going to start doing that to test out their changes. But then this leads to other problems like contention, for example. So you might be blocked on another engineer who's also testing their changes. It might also lead to general flakiness in your staging environment as well. So we're right now investing a lot in improving our local development workflow to combat that. And the final point here is minimizing contention. So yeah, we don't want engineers to be stepping on each other's toes. We've kind of, I think, solved this at the architectural level. So Monzo's quite well known for having a microservices architecture, which has always been quite controversial. And there's definitely pros and cons to that. And it's a topic for another talk. If anyone wants to chat to me about it after this, feel free. But it's definitely a longer conversation. But one of the really big benefits it gives us is the unit of deployment is very, very small. And this means that any of our services can be deployed entirely independently of any other service. And it just means that the probability that two engineers are going to be working on the same system or service is quite low. So I think we sort of mostly sidestep that problem by the nature of our architecture. So that's pretty much it. And this is, we've got a long way to go. I've mentioned some of the areas where we could still be investing. There's always improvements. There's always better automation. There's always, we can do any of this stuff better. And that's why I sort of focus more on the principles rather than anything else. I think whatever size company you work for, whatever your risk appetite is, as long as you stick to these principles, then you'll be able to ship very quickly and hopefully build what your customers really need, which is what's most important. So thank you very much, and I am happy to answer any questions you might have.
Thank you very much, Will. Right, we have got one from the online chat, which I'll do in a minute, but I'm going to, I imagine, we've got, if you are going to put your hand up, make sure you keep it up. Oh my goodness, right, okay. I'm going to start from the front, 1, 2, 3, 4 down there.
Hey, thanks very much, great presentation. The thing that freaks me out about continuous delivery with lots of different services is, in our environment, these services, as much as we try and decouple them, we kind of have to test a combination of versions of all the different services before we push them into production. So I'd be really scared to have totally independent deployment of separate microservices. I need to bring them all together in the higher environments and test them as a whole, a coherent whole, before promoting them to production. But you seem to not have that restriction. I'm curious how you've pulled that off.
Yeah, it's a good question. I think it's partly, so we have a mono repo, which is kind of unusual, I think. We have mono repo and microservices. So we do get a lot of, if we're making breaking changes to a service, we do get type checking that is going to break if you break the contract between services within the mono repo. But yeah, it's almost hard for me to imagine the problem in some ways. Are you saying that you need to check so you have multiple APIs exposed by a single service? Or
Well, if I change one service, I'm nervous about releasing that until I've tested it in combination with versions of all the other services to make sure that altogether they work well, because they're sharing complex data payloads, and even with strong contracts, little subtle nuances can break stuff. So I kind of want to say, right, version 1 of this, version 2 of that, version 3 of that, version 7 of that. That's a release candidate. Test it as a thing, and then move the whole thing as a thing into production. So it means we can't have this thousands of microservices all moving independently. Yeah,
I do go your point. It worked at least for us. It works surprisingly well. We invest quite a lot of it in acceptance tests, which do run, aside from them, everything is just testing the service in isolation, which I agree means that you lose a lot of the issues which can come from the interaction between services. And that's something we do test in our staging environment. We have acceptance tests which test at the system level. We're not, I should stress, we're not at full continuous delivery. So what we want to get to is where you merge the master, and that gets rolled out automatically, probably in a stage. We're investing it right now into progressive rollouts. So when you deploy, we're going to be checking. It'll just deploy to a small number of processes, and we'll be checking error rates and latency and that kind of thing, and rolling back if there's an issue. But yeah, aside from that, it is just acceptance tests in our staging environment, which we hope will pick up those kind of issues that you describe.
Cool, and over here.
So hopefully this is a question that's not a completely different topic, but you said about the culture of the small iterations, but do you also have a parallel line for something if you want to introduce something completely innovative that requires a bit more of a big bang, like a long-standing project? Or do you want to get there through incremental steps, but then are you always going to reach what you want to, or are you kind of stuck on a path that is, you can't deviate too much without 1,000 steps?
it's a good question. And I think the bias that we have is towards incrementalism. It's not always possible. There's definitely like certain migrations that I can think of, or bigger changes that do require that like big bang release, and that is just something that we need to be more careful about. But I guess my point here is that that should be in the vast minority of cases, and we don't want to have a change management process which optimizes for those cases. We want to optimize for the 95% of cases which are small. But yeah, in those cases we want to be much, much more careful. So yeah, and if you're talking about, you know, innovation and is incrementalism, I think the thing you're getting at is like, is there a risk that if you just take this incremental approach all the time, you get stuck in a like local optimal position, which I think is a risk. But I think on the whole, it's something that, like, as long as you're sort of aware of that risk with eyes wide open going into it, and sometimes you do need to push at something to get it fully finished and get to the end vision that you had in the first place, overall that's better. And if, for example, the business priorities change and you can no longer work on that thing, it's probably, I think, or we believe that getting halfway there is better than getting none of the way there. So, yeah, but it's definitely a risk to be aware of, for sure.
Sorry, I'll let the other people ask, but I guess part of that is if all the engineers are working in that way, do you reckon it limits the way you're thinking, that you're always thinking in an incremental way, so you miss out on the, like, you know, the shower thought, oh, this would be amazing, because you're always working towards an end goal?
Yeah, it's a very good point. I think I do like to think that we do a bit of both. So we have the vision, and then we start with the vision, and then roll that back to like small pieces that we can deliver incrementally. But maybe I just haven't worked somewhere that has gone for the big bang approach. But I think, yeah. On the whole, I think you can get the best of both worlds, but yeah, maybe there is some risk that you wouldn't be able to do like the really radical changes because they're just not feasible taking this incremental approach.
Cool. And then there was some at the back. One there. Do my little jog. Who was it?
As we scale, we are facing problems in terms of all these different teams exposing APIs. We use gRPC and we use proto-buffers for that. Any recommendation in terms of using those tools and detect breaking changes early?
Okay, yeah. So yeah, we also use protobuf as well for all of our service API interfaces. It's kind of the point I made before. We use everything's in a mono repo, so you get like type check errors if you make breaking changes. So you very quickly find out if a dependent service is broken by your change, which I think is a really nice property. Yeah. Aside from that, like I'd say we don't really do much in the way of like API versioning. So we pretty much just have like one version. We might have deprecated methods that are exposed, but typically I think what we want to err towards is like if you are a service that's dependent, if you own a service that's depended on and you want to make breaking changes, it's on you to update all of the call sites or users of that API. And this is something that, like, if you're working on an open source project, you can't do this. But if you're working with an organization that, you know, uses very opinionated set of like one programming language, and we actually like generate code based on the protobuf definitions and compile that code into the upstream and downstream services. So it becomes very, very clear when you do make breaking changes. And it's much easier to update services when you choose to make that breaking change.
Okay, cool. We've got one from the chat, and then there's only one after that. So from the chat, how do you propagate a blame-free culture further up the organisation structure Or being a startup, is this just embedded in naturally? I'm not sure about the phrase startup anymore, but...
Yeah, it's a good question. I have to think about that on the spot. What I always want to avoid is just saying, like, it's the culture, like, it's, you know, I think it probably does come a bit down to that, like, the early employees set a culture, and then, you know, people that like that culture are more likely to join the company, and it just sort of keeps going that way. But I do like to think about longest, you know, people leave the company, and the culture hopefully will be resilient to that. And I like to think about ways that, like more long-standing things like the tooling that I've described, which will encourage that longer term. And it's a really good question about the blame-free culture, because I'm trying to think, are there any like processes or practical things that we do that encourage that, other than just role modeling, which I think is a really, really big part of it. I don't know. I'm not sure. I think I might have to come back on that one. I have to think about it a bit more.
Asked all of the difficult questions
it's
today.
It's too good a question, that one.
Okay, that's we've had you're very popular with the questions, so there have been too many to answer. Are you coming to the drinks afterwards? Yeah. Okay, cool.
Yeah, talk to me after.
Okay, yeah. So if anyone else has still got questions outstanding, come and go afterwards. Everyone, give a big hand for Will, please. Right, so just whilst our final speaker is setting up, just a quick word from our other sponsor, Vonage, and this is Paul.
Hi, everyone. Thank you. This time you get me instead of Jim. First of all, thank you for having us. I think it's a pleasure to sponsor this sort of events. I won't keep you long. Vonage is a cloud communication company that enables developers to include voice, video, messaging inside their apps. So wherever you want to add voice calls to or video calls to your app, or build a Facebook bot, or send an SMS or anything of that sort, we have a very simple APIs to use. Developer.vonage.com is our developer portal. You find all the APIs there. The latest API we actually put GA, since we're talking about production deployments, is the Messages API, which allows you with a single API to send SMS, MMS, WhatsApp, Viber, I'm forgetting one, and Facebook Messenger. And that is a very simple. And on top of that, we have SDKs for various platforms. So if you need anything, speak to any one of us. Obviously, Jim is our insider here. So yeah, thank you very much again for having us, and it's a pleasure to be here and helping run this event. Thank you.
Thanks, Paul. Right, last and by no means least, we have who I described as Safari's biggest fan, who we obviously know that to be a lie and a joke. So we have Jake Archibald, who my favourite droll description from your site, from your blog. Check out Jake's blog; it's very active and there's a lot of cool stuff on there. Human boy working on web standards. It's like, okay, you can't really complain about that. That's pretty accurate.
Straight into the point. Yep.
So here to talk about web standards and some other cool stuff, and yeah, this is going to be interesting. So please give a warm welcome for everybody for Jake Archibald.
Hello. Oh, okay. This is my first talk since the pandemic. I've kind of forgotten what this is like. I'm kind of weirdly nervous about the whole thing, but sorry, what's the worst that can happen? No, seriously, what is the worst that can happen? Like, it's something that because I'm quite a panicker, so I feel like I have thought through every possible bad thing that can happen to me while giving a talk, and I think that I've come up with the worst one just through brute force. But I'd be interested to hear what you think. What's the worst thing that could happen in the next 30 minutes? So.
Grizzly bear rolls in and eats about 30 people.
Grizzly bear eats 30 people. I like that. I would say, the thing is, if it's rolling in from that direction, I would quite fancy my chance of escape. It wouldn't be the best talk I've ever given, but I think the fact that I survive, I'm kind of fine with that. And I think even you, sir, I think you've got a good chance as well. We'll be out that door, I reckon. Yeah. Any other ideas? Next slide transition doesn't work, especially talking about page transitions. Absolutely. Yeah, that's actually a strong contender I've seen. I've had friends that have gone through like just massive slide meltdowns. Someone I worked with, he went on stage. It was Chrome Dev Summit. He had his Mac plugged in, but I don't even know why this cable was there, but it turned out his Mac was plugged into a phone charger. So his Mac was just depleting the whole time. But it doesn't tell you that because a little charging icon comes on, but then at some point it just throttles the CPU to almost nothing, and all of his demos started failing. So yeah, that's a good one. I asked this of an audience once, and I was about to just move on and get on with the rest of my talk, and then someone at the back just shouted, "Get hit by a bus!" And I couldn't decide if it was an answer to the question or just like a suggestion. But I thought that was quite a good one, actually. Like, because yeah, if I'm here giving my talk and then just in comes a bus, particularly surprising here, we're on the second floor. But I think even that, it's, as I say, it's not a great way to end a talk, but the period of embarrassment would be brief for me. Like, the wall comes down, there's a bus, there would be a split second of, no, bus. And then it would all be over. And I'm kind of fine with that. Like I say, I've gone through all of them in my head, and I think the worst that could happen would be if I were to shit myself. And I'm not talking about like a big loud shitting. It would be a shitting that only I was aware of initially. And that's really key to it, because that would happen. I would know about it. You wouldn't know about it. What are my options at that point? Like, I know what I would want to do. I would want to just walk away. But then you would all be like, well, we came to watch a talk. You'd be on Twitter. Jake just walked out halfway through his talk, couldn't even be bothered finishing it. And I would feel terrible about that. So what I'd probably do is carry on. But then the smell would be slowly drifting as I was trying to carry on with the talk. And I have a front row seat to all of the reactions. So sort of based on how it would go, it would probably be you. I would be like, the page transitions in Chrome are quite good. And then at some point you would go, and you would turn to this guy and go, you farted? No, it's not. Might be him. You farted? No, not me either. No. And then at some point, a bunch of you would go, it's him. And it would be a moment of embarrassment that I would have to live with, and every time I close my eyes from that moment onwards, it would be that memory. So, I'm hoping that doesn't happen. Anything else is a win. And I have taken every precaution, so it should be fine. I kind of wish I was the first speaker of the night, because I would probably say this talk was about fluid dynamics and WebGL, and I would have pretended like all of these patterns in the background was a live demo that I'd coded. You'd all think I was very smart, but I can't get away with that now. We've all been watching that. I'm here to talk to you about a feature that I've wanted on the web for years now. I am talking about page transitions. I mean this kind of thing. Like, I look at this in the material design guides, and it's just joyful, isn't it? And it's not just a fancy visual either. It gives the user context to the navigation. It's clear where the information is coming from and which direction of travel you are. You know if you're going forwards, you know if you're going backwards, that kind of thing. Whereas on the web, it's just click, pop, that's your lot. Why can't we have nice things on the web? Well, one reason is that page transitions involve parts of the old thing and the new thing animating together. But on the web, when you navigate, the old document goes away and the new one arrives, and there's no opportunity for the two to work together. But that's only true with traditional web navigations, what we often call MPA now. With single-page apps, you're driving the state change yourself, so you can do whatever you want. Imagine quite a lot of you here might probably work on like an SPA kind of website, SPA kind of system. There isn't exactly a shortage of them out there, so why don't we see lots of sites doing fancy transitions? Well, the truth is, it's kind of hard with the APIs that we have today. Like even something like a simple fade is hard. How would you keep both states alive for the duration of the transition? It isn't particularly easy in modern frameworks. Svelte gets pretty close, but still got quite a lot of bugs. And there's lots of subtle accessibility and usability issues of having both copies of the DOM around at the same time. If you're going from a scroll page back to a page that's up at the top, like how would you handle that? If either of the states contains an iframe, how would you juggle that around without it resetting? Because iframes reset their state when you move them around a DOM for whatever reason. If you wanted to create a transition where this element in this scrollable container moves across to the other scrollable container, you might have hit this problem before. It's in a box that has clipping, so it doesn't work. To make this work, you would need to temporarily pop the element out to the root of the page, and if you've worked with CSS before, you'll know that that means you'll have to change how you've structured your CSS so that element can exist at the root. I'm not saying it's impossible, but it's not easy. Meanwhile, folks on Android and iOS have dedicated APIs that make this kind of thing a breeze. And as a web developer, I just don't think that's fair. Like, I want to be able to do this kind of stuff. So we've been experimenting with an API. I work on Chrome, by the way. Should have started with an introduction. So when I say we, that's what I mean. On an API to level the playing field here. But it is something that's been tried many times before. We're not the first. Back in 2015, a group of folks in Chrome, they had a proposal. They even had a rough implementation. They demoed it at Chrome Dev Summit. But it was a fairly restrictive API. It didn't really pan out. In that same year, Chris Lord, who worked at Mozilla at the time, he wrote a proposal, didn't go anywhere. I wrote a proposal the next year, a couple of years later, didn't go anywhere. Tab Atkins, one of the people who does a lot of CSS work, he wrote a proposal, didn't go anywhere. We had a thing called the portal element. It's still something we're working on. It lets you do some transition kind of things, but this year we are trying to ship a feature that is purely focused on page transitions. But we're not even the first to ship a feature like this. Internet Explorer actually did some time ago. This is how it worked. You put this in your page, this little meta thing, and so this is a page enter thing. You say, I'm going to have transition number 6. And transition number 6 is wipe from the right. You had 22 to choose from. It was kind of a few basic ones, and then they multiplied by different directions. Oh, plus a special 23rd transition, which was to pick a random one each time. That was a lot of fun. Does anyone recognize this? Did anyone actually play with this in Internet Explorer days? We got a couple of hands at the back, but not many. It makes me feel quite old. I think, Stuart, you might have nominated yourself to answer this next question. What year was this? 2006. That is not even remotely close. 1997. This was Internet Explorer 4. I maybe should have given you that clue. But to put that into perspective, that is a year before Bewitched released C'est La Vie, the greatest song in the world. And only a few years after 1992, which is the year Marty McFly would travel back to if Back to the Future was made today, which is a horrifying thought. So it's fair to say there's been a lot of false starts to this feature throughout the history of the web, history of browsers. But this time, it feels like we're really close. Like, I'm going to take this basic site. This is a demo site I built to kind of demo this effect. I built it for Google I/O, where the lawyers are very touchy, and they're watching all of the imagery and asking you if you've got the rights to it, which is why it's pictures of me. Not something I would usually do, but it's easy for me to prove to them that I have the rights to my own face. So you get to see it now as well. This is a single-page app, because that's what the experimental stuff in Canary supports right now. But don't worry, the whole system is designed to work in a very similar way for multi-page apps. Because I'm very much aware that that is what a lot of people really want this API for. It's just that we haven't implemented it yet. It might actually be the next thing we look at implementing. But seriously, the whole design is built around the restrictions that would come with just a regular web navigation, or MPA as we tend to call it now. All right, here's a rough example of how navigations are currently handled. Let's add some transitions to that. First up, I'm going to add a fallback for browsers that don't support this new API, so things continue to work as normal, don't break in other browsers. Otherwise, I'm going to create a transition and start it, letting the API know when the DOM change is complete. We might change some bits of this. We might change some of the naming. I want us to change start to prepare. I think it makes more sense. But the pattern should remain the same. The important part is that the API gets to see the state of things before and after the DOM change. And just like that, you get this nice subtle fade between states. All right, fading isn't really interesting, so let's do something better. But to do that, we need to understand how this fading thing actually worked. First up, the browser took what was essentially a screenshot of the page and held it in place while we were able to change the DOM, change the page underneath. Then it created a DOM structure like this out of CSS pseudo elements, and that contains both a screenshot of the previous state and a live representation of the current state, but also as a flattened image. This element structure sits over the top of everything, hiding the real DOM underneath. The outgoing image fades from opacity 1 to 0, and the incoming image fades from 0 to 1, and that is your crossfade. Once it's done, it goes away, seamlessly revealing the real page underneath. But like all my favorite APIs, this is mostly built of existing platform primitives, so you can mess around with them. For instance, each of these elements can be targeted using CSS pseudo element selectors, and all the animations are driven by CSS, so you can change what they do using CSS. Like I said, the incoming and outgoing images, they crossfade, so let's just set a longer animation duration. And the result of that, we get this super slow crossfade. All right, fair enough, but let's do more. Let's change that animation completely. I'm going to define some CSS keyframes, just the usual way. Define slide to left, which slides the element out to the left, and this slides the element in from the right. Now I'm going to use them. I'm going to slide the outgoing image to the left and the incoming image in from the right, just using normal CSS animations. And the result of that was pretty good, not bad. There are a couple of things that could be better. Firstly, it's always sliding in the same direction, even when we click the back button. Ideally it should slide the other way. We can look at that later. The other thing is the header slides out across the top there. So it slides out only to slide back in again. That doesn't feel right. It's kind of the same element in both states. You would hope that it would just stay static. And that's something that the page transition API lets us do. So what I'm going to do here is assign a page transition tag to the header just using CSS. Site header is just an identifier. You can pick any identifier you want, just in the same way that you can name like grid cells in CSS grid. I'm also going to give it paint containment, which is just a restriction of the implementation that we currently have. This changes how the page is captured. Previously, the page was being captured as a single screenshot, but when you give the element a page transition tag, it is captured separately, still just as a screenshot. So now we have incoming and outgoing images for the root and separate incoming and outgoing images for the header. In the same way we got one of these structures for the root of the page, we get another of these structures representing the header. Now that's something we can target with CSS, using the page transition tag we assigned it, which is site header in this case. That means we can animate it independently of the rest of the page. But I'm not going to do that. I'm just going to let it do the default thing. And here's how it looks now. Yeah, we haven't told it how to animate, so it's doing the default, which is to crossfade. And that looks pretty good. Not bad at all. But we can do even better with one small change. As well as capturing the header as its own transition part, let's also capture the text in the header as a separate part. Same as before, we do that by adding this page transition tag to the element. And here's how it looks. I think that's pretty neat. Like, I already mentioned that the default transition is a crossfade, but I left a little detail out. It also transitions the size and position of the element from its before state to its after state. And that didn't matter for the root or for the header because they were the same size and shape and position before and after the DOM change. But for our heading text, it does this nice, satisfying little shift across to make space for the back button. I really like how it's just making little small additions and adjustments to create a transition that is really tailored for this particular demo. Also, those three parts that form the transition, the title, the header, the root, they have a flat structure during the transition, even though in our real DOM, the site title is inside the header, and the header is somewhere within the root. They're treated as siblings in the transition, and I think that's a good thing. This example from earlier, we couldn't move this from one container to another because it would be clipped by its current container. With the flat structure of page transitions, it isn't a problem because it's all flattened. All right, so we've got these three parts, all transitioning position, size, and crossfading their contents. It didn't look like the site title was crossfading because it was, it's the same thing in both states. It just moves position. But it would still look good if the title was slightly different. It would just do a nice crossfade. And making that work in browsers wasn't entirely straightforward. In fact, it was impossible until relatively recently, especially for the heading text, because that includes transparency. Let's say you wanted to crossfade Fusion with the word vision. There we go, easy peasy. All I did there was just fade the new element over the top. But what if I introduce transparency? Well, I can't just use the same technique. I can't just fade the new thing over the top, because you just get a clash of both of them because of the transparency. So what would you do? I think what a lot of people have done in the past is, well, what if I fade the old thing away while fading the new thing in? But that doesn't quite work. There are parts of this that are exactly the same between both states, particularly the S, the I, the O, and the N. They're the same in both states, so we wouldn't expect them to change in any way. But if you look at it closely, you can see it's sort of slightly fading out to fade back in. You can see those squares from the background showing up. In fact, if I lock it at 50% there, you can see that semi-transparent state. And not just that, it's the parts of the text here which intersect. Again, in those parts, it's going from a solid blue pixel to a solid blue pixel in a crossfade, but we can clearly see transparency in those areas, so this is not adding up. The problem here is how default compositing works in browsers, which tries to mirror how things work in the real world. And if you take two pieces of plastic which block out 50% of light and you put them on top of each other, you can still see through them because the first one blocks 50% of the light and then the next one blocks 50% of the remaining light, leaving you with 25% of the light. And that's how the real world works. And it's how default compositing works for that reason. Here we've got two red squares with 50% opacity and two blue squares with 50% opacity. We put them on top of each other. It's different. Why is it different? It's different because in this example, the blue is on top, and in this example, the red is on top. Again, it's how the real world works in terms of compositing. But with a crossfade, the order shouldn't matter because 50% should be halfway between the two things. It doesn't matter which one's on top and which one's underneath. So to fix this, we shipped a new compositing mode. We pitched this to the CSS working group. The name might seem weird, but it's what a lot of popular old papers about compositing call it. And we wrote a spec and test for it. And this is now shipped in Chrome and Firefox and Safari. It's across all browsers now. And this is how it works. On the left, we have normal compositing. On the right, we have plus lighter. And that's the difference. It gives us this effect we want, like half transparency plus half transparency equals fully opaque in this example. This was a feature that we needed for page transitions because we knew we were going to be doing all of this crossfading, but we shipped it in a way that you can use for any element. So if you wanted to do your own crossfading, you would do something like this. You create a container, and then you have your two parts in there, the from state and the to state, and then you want to position the from and the to on top of each other. And here's how I do that. This is my favorite way of doing this now. Usually I would use like position absolute and do it manually. I quite like this technique where you create a grid and then just tell it all of the children should be in the same cell. I like this technique because the container will then become a layout big enough to hold all of the contents, which doesn't happen with position absolute. You don't have to do it that way, I just find it handy. And then what I'm going to do here is hide the to image, give it opacity 0, and then add this new blend mode on the to there. I'm also going to say isolate on the container. And the reason for this is we're changing the blend mode of the to item here, and the way a blend mode is going to work, it's going to blend with anything that's in the background, which isn't what we want. We don't want it to blend with whatever's right behind all of the things. We only want it to blend with the from image. And that isolate does that. It creates a barrier where it won't blend with anything outside of that container. And so now, if you hover over that element, that container, it will crossfade the to and from images just by transitioning on opacity. We'll make the to image go to 1 and the from image go down to 0. And that will work out. So unlike before, where the crossfading wasn't quite right because the midway crossfade had this semi-transparency, If we switch now to plus lighter, it does the right thing. On the pixels that intersect, they don't change. You get that solid blue, and you get this proper crossfade where the SION is not changing at all. So although we're designing this high-level page transition feature, we're still trying to break it down into lower-level components that can be used anywhere. All right, back to the site. Things are looking pretty good here, but what about on desktop? It kind of feels, I don't know, a bit much. Like that transition that was working very nicely on mobile is like the whole page just swinging across just feels a bit, I don't know, kind of nauseating. But put the sick bucket away because we can solve this the usual way that we solve responsive design issues. Here are the transition styles for the root. This is just CSS. And now I'm going to create a media query to say when the browser is 660 pixels wide or more, I'm going to add some different keyframes. I can change the animation in that case. That means we can keep the previous transitions on mobile, where things slide fully from the side. But over on desktop, we can have something a bit more subtle, where it does just a little slide and a crossfade at the same time. So it still communicates the direction of travel, but it's not moving the whole thing across. I don't know. I just made this up. I'm not a designer. You can probably think of something better. But while we're being responsive, here's the code from earlier that triggers that transition. Currently, the transition is skipped if the browser doesn't support the API, which is great. But let's also add this. This is a media query. We can test to see if this user prefers reduced motion. And that becomes true depending on their operating system settings. If they've indicated to the operating system that they don't like a lot of motion, we can pick that up on the web. Now, you don't have to do this. You don't have to just cancel all of the transitions if the user prefers reduced motion. You might want to create like a more subtle transition in that case. It prefers reduced motion, not prefers no motion. And in some cases, a subtle transition can be better than a switch for people who prefer reduced motion. But this is a lazy approach, but that's the approach I'm going to take in this demo. All right, what else can we do? OK, I'm going to take this large video embed here, and I'm going to make that its own element in the transition. But the video embed only exists on this page. It doesn't exist on the thumbnails page. And that's fine. You can create transition layers that only have an outgoing or an incoming component. It's a pretty common thing to do as things appear and disappear. But that's not what we're going to do here. So here's the rough code for when one of those thumbnails is clicked. Using inline styles, I can say, treat this as the video embed. It's not actually the video embed. It's just the thumbnail. But for the sake of the transition, we're going to say the thumbnail is the before state of the real video embed. And the effect of this, you ready? Ooh, there we go. The thumbnail now grows into the main embed. It doesn't matter that there are different elements in the DOM. We told the page transition API to treat them as the same thing, so that's what it did. And what you saw there was just the default transition. Like it moves from its before position and size to its final position and size whilst crossfading the content. Here's an even more developed example. I've made the video pop back in place when going back to the thumbnails view. I made the sidebar slide in the first time but stay static in the other cases. I made the video description kind of expand out from the thumbnail as well. I don't know, maybe this is too much. Like I said, I'm not a designer. I'm just playing around with new toys. It's probably way over the top. I felt like a little bit when I first discovered Photoshop and I found the effects panel and I found out that you could do lens flares. And I was like, that's amazing. That was one click. I'm putting one of those bad boys in every photo I take. In fact, one. Why not more? Look, it can only improve a photo. It took a while for me to figure out that just throwing all of the effects at it probably wasn't the answer, and something more subtle is probably the right thing to do. By the way, when I made those pictures, I'd not looked in that panel in Photoshop for a while. I didn't realize that Photoshop had added even more ridiculous effects. Did you know that Photoshop can render trees now? Like foliage. It has foliage generation. I would love to have been in that meeting where someone went, we need a foliage generation system in Photoshop, but they have one. I didn't know about it, but I do now, so I know what's happening. Every picture of my cat is going to have trees for ears. You can't put that option there and not expect me to use it. But seriously, maybe you can do better than this, so give it a go. This is all running in Chrome Canary using the Page Transition API today. Another thing we're adding, we're doing work currently on DevTools. One thing we kind of got for free actually is in the animation panel in Chrome. This has been around for quite a long time. Because all of our transitions are CSS based, we get this dev tool for free. So what I'm going to do is I'm going to tell it to pause all animations, and I'm going to click that link. Nothing happens because the animation's paused, but it's kind of appeared in the panel there. So I can go in there and click it and then fully inspect the animation. This is a really nice technique for kind of figuring out where if there's any glitches in the animation, if something, because the transitions are quite fast. This lets you really sort of drill down frame by frame and see if something's going not as you expect. Another bit we're working on is just in the regular elements panel, exposing all of these transition elements. Right now, they're all named the same thing. That's not great. So we're actively working on this. We'll add the proper names in there as well. But it lets you go in and see how the CSS is applying to each of these elements and change it and debug it. I mean, I'm really excited about this feature because I feel it's got reasonable defaults. But with little bits of CSS and JavaScript, so you can make the transition as custom as you want. And really, in many ways, this is thanks to you folks, thanks to web developers, I guess, specifically. We released a different version of this API last year, and it didn't use CSS animations. And the transitions were restricted to a few presets, really. And I didn't like it. I wasn't happy with it at all, and I fed back that I wasn't happy with it. I said, this feels a little bit like the old IE thing that we didn't like. But folks internally felt like it was good enough for 90% of cases, so let's just go ahead and stick with the simple thing. So I wrote this article sort of showing how to use it, and I wasn't negative. I kind of held my tongue and was just like, yeah, we've got this thing. You can do some stuff with it. But what I was really hoping for was developer reaction like this, where it was like, yeah, this looks good, but can you please just make it lower level so we can customize these transitions? And seeing this was music to my ears, because I was able to just take a load of tweets like this and just dump it on the desk of the people senior to me and say, look, it's not just me saying this. This is lots of developers. And as a result of that, that's what drove the second version of this API. That's what convinced people. So if you ever feel like, I don't know, giving feedback on features like this is so important because it gives me the fodder I need to actually make meaningful change in the browser. So if you want to have a play with this sort of thing, we've got a developer guide which covers everything I've mentioned and more. I could go on for hours. I've actually got more slides and demos, but I vaguely remember that one of the benefits of in-person events is being able to take questions. And now seems like a good point for that. So does anyone have anything?
Thank you very much, first of all.
Oh, I'm not done.
You didn't expect the applause.
I'll take it.
I'll take the
Hang
applause.
on, does that mean I don't get an applause at the actual end of the talk? Because I just used up my
You get applause at the pub.
Okay, good. I'll take that.
Right, okay. Well, this is going to have to be first come, first served, so I'm just going to see them go. One has gone up there. We do have a few online as well, so I'll
cool.
make sure those come in. Where was our hand, Aaron?
So I noticed in your pseudocode example of a page transition, you specifically had to await the fetching of data before performing the transition. And I was actually wondering if there was any facility to trigger a transition and fetch the data while the transition was happening, potentially even hide latency in an app if it was quite a costly request.
Yeah, absolutely. So you're dealing with the two images as part of the transition. And the before image is a snapshot because that part of the DOM is gone. But the to part is a live image. So anything you update in the DOM in the background, that change will be reflected in that image. So you could, as part of your navigation, start the transition immediately to a skeleton page, and then start populating the DOM underneath as your request comes through. Or you could deliberately wait for after a transition to the skeleton page, and then hopefully you've already got your data by then, and you could just dump that on the page. One comment I actually got is a lot of people were saying is this not going to make pages slower because now we're going to have to wait for all of the transitions? And if you write it yes, if you do wait for all the data and then do a transition, yes, I guess it's ultimately longer by the length of the transition. But yes, I think the real advantage here is that you could kick off the transition straight away to something you've already got, even if it's just dummy content boxes and stuff. And what actually happens is the motion of that transition gains you a bigger sense, feeling of performance because you've distracted the user with a fancy animation, whilst what you're actually doing in the background is making a network request.
That's really cool, thank you.
Cool, and also thank you for that question, because that answers one of the online questions, which is how much would page transitions affect speed and performance of a website, and I believe that's just been answered. Another one from online. Why are the status codes HTTP 203 instead of 200?
Yeah, so I do a YouTube show called HTTP 203, which is what I was using there. I maybe should have explained that. So it's a podcast and a YouTube show that we do, and when we came to name it, we thought, let's have a look at the status codes and see if there's anything funny in there. And we went through, and there's the HTTP, is it 412, which is the I am a teapot HTTP status, but we felt like that's a kind of a joke people know about a lot. And we went down and we just looked at 203, and it was non-authoritative content. And we thought, well, if a couple of us are going to do a show together, that sounds like the ideal name, because we don't really know what we're talking about.
I didn't expect it to be an in-joke. That's quite good. Over here.
Is there some control in the browser that you can use to switch off the effects in case you get motion sickness, or it's just annoying, or you have visual problems?
So this is, that question has come up before. I don't think we're going to add an option in the browser for that specifically in the same way that we haven't added it for animations in general. Because I think what will happen is, if we ship this way of doing page transitions that people will use subtly and correctly in a way that even people who don't want a lot of motion, they're going to create subtle motion in that case. If we create an option to disable that, then the people who want to do the right thing are going to go, right, well, I'm going to go back to the old system of doing it. That's going to require a ton of libraries and be slower to download because there isn't a button to disable that one. So the way we're going to play it is by, a bit like I did before, promoting the operating system, reacting to the operating system, the user's wish via the operating system that they prefer reduced motion. Because if someone is sensitive to flashing, imagery, with epilepsy, a small fade can actually be much better than something that would chop a couple of times, with layout shifting. So yeah, with a web extension, because this is all CSS, you could write a user style sheet which forces all of these animations to not happen. In the same way you could do that with all animations on the web. So we would welcome extension developers to do that, but I don't think we're going to provide a single option for that just for this API, because it will just push people back to the old bloated way of doing it.
Cool. Any more? Over here.
Hi, is this just a standalone project, or it is a part of a series where Google wants to bring the web experience closer to the ecosystem? I mean, the operating system.
So we have, there's a project internal at Google at Chrome called Fugu, and they're specifically tasked with bringing new capabilities to the web. So this is the team that has brought things like the Bluetooth API, the Web Serial API, the USB API, these reading fonts on the local system, trying to bring the web closer to what native apps can do. So I would say that. So I was involved in a project called Service Workers years and years ago, and that was about enabling offline experiences on the web, and also things like push messages. So I think this is a long journey that we have been on for at least the last decade. This particular feature doesn't sit with the Fugu team because it sort of more comfortably sits with the CSS stuff, but I mean it's part of the general mission of just really kind of making the web more powerful.
Cool. Any more? No hands. Right.
I had a question on YouTube that just said can you do something like a star wipe transition? What kind of things can you do with this? And I thought, I'll give it a go. So the way I would do something like this, I'm going to disable the default CSS animations between the outgoing and incoming images, because I think we need JavaScript to do this particular animation. Here's how you do a web animation, API animation. So when you're targeting a pseudo element, you start with the parent element, which is the document element, which is the HTML element. And then you specify which pseudo element you're interested in. I'm not keen on this pattern, but it's the one we've had for years. We're looking in ways of making this, giving developers more of a first-class access to pseudo elements. Anyway, what I'm going to do here, I'm going to animate a clip path, which crops the element to a particular shape. I'm going to go from a circle in the middle there to a circle that has a radius in the furthest corner, so that, that will cover the whole element. Unfortunately, although radial gradients have this farthest corner keyword, the circle function does not, so otherwise we would be able to do this entire transition in CSS. But we can't do that, so we have to do it manually. So I'm going to get the middle of the page there, and then do a little bit of Pythagoras to find out what the radius to the corner would be, and I can replace that there. And here's what that looks like. Woo! There we go. Now I know what you're thinking. That's not a star. Okay, chill out. Let's make it a star. If, like me, you've forgotten most of what you were taught about trigonometry, or maybe you weren't taught about it in the first place, DOM matrix and DOM point are your friends here. These are well-supported APIs, and we're going to use them to draw a star. So first up, I'm going to write a function that takes an x, y, a size, and a number of points. 10 points for your classic star, but we'll make it configurable. You could have any number of points. I'm going to return an array of points here, and to do that, what I'm going to do is return a bunch of DOM points. So here I'm creating a DOM matrix, and I'm going to transform a point, and I'm going to create a new point there. Because it's a new point, it's at 0, 0. The matrix isn't doing anything, so all of the points are going to be at 0, 0. There they are, 10 of them, all in the same place, utterly useless. But let's translate them by -1 on the y-axis. And ooh, there we go, still useless. But what if I rotate each one by a fraction of 360 degrees? So if it's 10 points, the first one will be rotated by 0/10 of 360 degrees, 0 degrees. Second one will be 1/10 of 360 degrees, 36 degrees. Then 670, I don't know. The whole point of this is I don't have to do the maths myself. And there we go. This looks a bit like this. There we go. We have successfully drawn a decadon, which sounds like a monster from Stranger Things, but more importantly, still not a star. But I'm going to use the modulus operator here. Rather than move that point -1, I'm going to move the odd ones, -2, and the even ones -1. Or is it the other way around? Doesn't matter, because there's your star. OK. To finish it off, we'll let it be translated and scaled according to the input, so we can change its size and position. So how do we make this work in CSS? CSS supports this polygon method. It also supports SVG paths, but this is, I think, an easier syntax to read. So here's a function. I'm going to take those points and create those x and y pairs there at the top, and then join them by a comma. And that should give us this polygon syntax once we put the word polygon and brackets either side of it. So we're back here. We still need the x and y and the radius, but we'll add in our 10 points there. And instead of the circles, we'll add in our methods for creating a star and converting that to this polygon format. And there you go. We have star. Thank you. Yeah. And then they said, no, sorry, I meant a Star Wars transition. Fine. OK, let's figure out the basics of this. We're going to create a gradient. So it's fading from transparent, and then just the little bit in the middle there fade to black. Great. I'm going to change the background size of that, 210%. Now, because this is a background, you wouldn't normally see this bit. It would be clipped by the box. I'm just showing you what it looks like. This is at its 0 position, but if we move it to its 100 position, it does that. There we go. But like I said, it would be clipped by the box, so that effect would be like that. Great. OK. But how do we make this work in a page transition? So I'm not actually going to make it a background. I'm going to use WebKit mask image, which is this old WebKit property. Firefox has it as mask image, but Chrome, you need to put the prefix on there. So this makes the element, well, it applies it as a mask. So parts of the mask which are opaque, it will show the element. Parts of it which are semi-transparent, it will apply that semi-transparency. So I'm going to create an animation that moves that position from 0 to 100, like we saw before. And then I'm going to apply that animation, 1.5 seconds linear. And so the incoming image is transparent to black. The outgoing image is black to transparent. And so it's like the opposing one. One is going to sort of start generally like reveal itself, and the other one is going to unreveal itself, whatever the proper word for that is. And the result is, there you go. OK. Now we have a Star Wars transition. Any more questions? Yes, switch controller. The browser supports the gamepad API. So I feel like almost this is, there's not enough imagination here. I at some point just want to come on with like a rock band guitar and do my slides like that and never mention it, refuse to answer any questions about it, but change all my slides that way. Yeah, this is, the Wiimote was like its own special Bluetooth protocol, where this is just BTLE standard gamepad thing, so you can just connect it to a Mac or to Windows. And as soon as you do that, the browser recognizes it as a gamepad. So I've just got a little bit of code in the background just listening for button presses, and it does the right thing.
There's Jurassic Park in my head of your scientists were so preoccupied about whether they could, they didn't think about whether they should, but it was still absolutely awe-inspiring.
People are going to create terrible transitions with this, in the same way that we saw with like the lens flares and stuff. So I think it's down to, well, I guess people like me, but like designers as well, to kind of promote good practice, to do the, not create things that are too like nauseating, to pay attention to that operating system setting and yeah, do the right thing. I think our general rule to people is going to be make your page transition and then half the length of time it takes, and then half it again. Because the default is always to create like a big cinematic transition, but you really just want something that feels pretty responsive.
If you've done the old school Star Wars wipe, then surely with J.J. Abrams, live lens flares.
That would, that would be 100 lens flares come in. Yeah, absolutely, you could do that.
Cool, right. I think that is it, unless anyone's got any more questions. There is one. Last one of the night.
Thank you. It's more of a conceptual question. You used the mobile operating system as inspiration for this. And in those cases, most of the transitions are not necessarily page transitions, but element transitions from different bits in the page. So I'm wondering, is there a way, and I'm not sure if you're familiar in Keynote with Magic Move, like the way element moves, something like that where maybe the browser will kind of analyze the existing page of the next one and see the kind of the common elements like that thumbnail, for example, and just have a transition done dynamically without you having to do much, but it makes it a bit easier to use. And in the same way, is there a way the browser will go the same way kind of operating systems will go? Like, what you have there is a navigation controller in iOS, for example. Is that something that you have in mind for interfaces? Because it makes it a bit more intuitive to navigate, obviously. I mean, I would argue that the thumbnails need to be on the left, at least for the left to right systems. But, just to make it a bit easier to understand the navigation, because I'm guessing that's the purpose of the whole exercise.
So in terms of the Magic Move thing, it feels like pretty close already. The only thing we need on the web is those page transition tags to identify, like, we need to provide the developer a way to say that this thing is actually the same as the thing before. Because even in, well, I guess with the thumbnail to the large embed thing, those were different DOM elements, but the transition should make them appear like they were the same thing. For cases where the element is literally the same, I would worry that if we just did that for everything that moved, I mean, you could create a script which did it, right? Just give every element a unique name and it would do that itself. But I think you would end up with something that kind of looked like the bad old days of Flash when they had that kind of morph tweening and everything would do sort of nonsensical kind of motion. So I think, yeah, it would be nice to... Okay. Web standards people, and I am kind of one of those to some degree as well. Sometimes I'm a web developer, sometimes I'm a standards person, but we're not always the best people to design features because to work on web standards, it's such a time sink that the people who work on web standards don't tend to be working on long-term web projects. We tend to be sort of building demos like this. So what we would do, I think, for the next phase of this API is release what we've got, which lets you do everything, but maybe requires a bit more code, and then identify the common patterns and then pave those cow paths. That's kind of my favorite way of adding features to the platform because it's developer-led, rather than some web standards person thinking they know what web developers do, even though they're really detached from that process now.
Cool. Well, in that case, thank you. A big round of applause for Jake Archibald, everyone.
Thank you very much.
And to do our sort of final sign-off stuff, our thanks to everybody. So thanks to my team first of all. So that's Mike at the back and James Vickery and Indy volunteering, and for Alistair Hay and for Luke Brown for helping out. Like I said, if you've got any questions about meetups and things like that, then speak to them. We are going to be going to Cozy Club for the after party afterwards. If you don't know where that is, follow me or Luke is at the back, and we will do, our sort of tourist thing where we like Brummy guides, like, all right, this way to the pub. And so, yes, obviously the final thank yous are to first of all to you for coming, and I hope that you enjoyed it. Give yourselves a round of applause. And obviously to our sponsors, Vonage and Goldman Sachs, who make this happen. And finally to our creators, Andy and Hannah, who have a decent enough excuse to not be here, in that Hannah gave birth a couple of days ago, but has still been on the Discord giving us orders. So thanks to Hannah and Andy. So, it just remains me to say thanks to our speakers. I'm going to miss out someone. Thank you to all of our fantastic speakers, Will, James, and Jake. And thank you very much, and good night.